Okay, now we are going to balance different ionic equations in basic medium. That's the important part, basic medium, right? Now, the first step will be to find out the oxidation states. So let's start. The oxidation states here, manganese is +7, whereas manganese here is +4, +7 and +4. So the difference between those two, +7 and +4, difference is 3. That 3 comes in front of oxalate ion. That 3 comes in front of oxalate ion. And then talking about oxalate in oxalate carbon is +3, and in carbonate carbon is +4. All right, fine. Now from +3 to +4, +3 to +4 difference is 1, but there are 2 carbon atoms here, correct? There are 2 carbon atoms, therefore you should put 2 here. You should multiply that by 2 and put it here. Okay, right. Then we have to balance the components on the right side. 2 manganese, I have to put a 2 here. 6 carbon, careful, 6 carbon, so I have to put a 6 here. I have to put a 6 here. Right. And the next step is going to be balancing the charges. All right. What is the total charge we have here? The total charge we have here is -8. -8. That is the total charge we have here. How is that? 2 minus -6 here. 2 into -1, 3 into -2, -6, and -2, -8. And here we have -12. How did that -12 come? 6 into -2, that is -12. Here -8, here -12. This side is more dominant with minus, therefore OH minus must be added to left side. That's the only way you can balance the charges. You have to balance the charges. Here, if it is -12 here also it should be -12. To get that, you put OH minus, right? Fine. And the final step is going to be balancing hydrogen atoms. So how do you balance hydrogen atoms? To balance hydrogen atoms, we have to add 4 hydrogen atoms here, 4 hydrogen atoms on the left side. That's all. On the right side, I have to put 2 water molecules. I have to put 2 water molecules and balance it out like this. 2 water molecules and it's balanced. Okay, right. Hope everyone understood that. And to confirm that your answer is correct, you have to count oxygen atoms and recheck it. 8 plus 12 plus 4. 8, here it's 12, 4. 8 plus 12 plus 4 is 24 on the left side. On the right side, 4 plus 18 plus 2. 24 on the left right side. 24 on the left side, 24 on the right side. Now the next one, we have chromate and sulfur dioxide. In chromate, it's chromium is +6. In chromate, chromium is +6. In sulfur dioxide, sulfur is +4. And here, sulfur is +6, whereas chromium is +3. Chromium from +6 has gone to +3. Therefore, the difference is 3. That 3 comes here. Sulfur from +4 has gone to +6. Therefore, a 2 comes here. 2 chromium, we put that here. 3 sulfur, we put that here. And next step, balancing the charges. On the left-hand side, you have -4 charge. On the right-hand side, you have 0 charge. Why is that? -6 plus 6. So the total charge is 0. Here, -4. Therefore, I have to put 4 OH minus on the right side this time. Because the charges, here we have negative. So the negative charge should be put on the other side to balance the charges. And then you have to balance the water molecules. We have 4 on the left-hand side. Therefore, I just have to put 2 water molecules on the right-hand side. And what do we do to confirm whether we have done it correct? Count oxygen atoms. 8, 6, 2, 16 on the left-hand side. 12, 4, 16 on the right-hand side. That's done. Next one. Permanganate reacting with H2O2. Permanganate from +7 has gone to +4. In H2O2, each oxygen is -1, and they have gone to 0 in oxygen. Now, permanganate from +7 to +4, difference is 3. That 3 comes in front of H2O2. In H2O2, oxygen -1 to 0, difference is 1, but there are 2 oxygen atoms, therefore you put a 2 in front of manganese. With that 2, you balance manganese. And careful, whenever you have H2O2 and O2, with whatever the number we have in front of H2O2, you have to balance oxygen. We have done it before in the previous examples as well. Whenever H2O2 is undergoing oxidation, oxygen must be balanced using the stoichiometric coefficient in front of H2O2. Okay, now you can't, when you want to balance oxygen, you can't count this oxygen. You have to balance that only with, because H2O2 is the one which turned to O2. Right. Now, next step is comparing charges. On the left side, -2. On the right side, nothing, 0. Because nothing is negatively charged here, correct? So I have to put 2OH minus 1 on the right hand side. 2OH minus 1 on the right hand side. And now we have to be careful with balancing water. Now I can't just put a water here because there's already hydrogen atoms on the left hand side, correct? We have 6 on the left hand side, we have 2 on the right hand side, and water is scarce. Sorry, hydrogen atoms, we have a scarce here. It's scarce here. 6 here too. So I have to put 2 more water molecules on the right hand side to balance out hydrogen. So we have 6 hydrogen on the right side, 6 hydrogen on the left hand side. To make sure that you have done it correctly, what do you have to do? You have to count oxygen atoms. 8, 6, 14 on the left hand side, 6, 10, 12, 14 on the right hand side. 14 on the left hand side, 14 on the right hand side. That's it. Here you have to be a little careful. Both OH minus and water are going to be on the same side. Next one. Let's start quickly. Chromium +3. Chromium is +3. In H2O2, oxygen is -1. And here in chromium, here it's +6. Chromate, actually. Chromate. In water, hydrogen is -2. Here, chromium 3+ is getting oxidized. H2O2 should get reduced. Careful, all right? So if you talk about chromium, from +3 to +6, difference is 3. So I put a 3 here. Whereas in oxygen, -1 to -2, difference is 1, but there are 2 oxygen atoms here. Therefore, I have to put a 2 here. -1 to -2, difference is 1. There are 2 oxygen atoms here, so that difference must be multiplied by 2. Right. 2 chromium ions, I have to put a 2 here. Right. That's all you can do at the moment. Don't try to balance hydrogen because you have to put OH minus. Then you go and go balance higher charges. +6 here on the left hand side. On the right hand side, -4. Right hand side, -4. Right. So to which side should we add OH minus? Here, plus is dominating, but here, minus. If I put OH minus to the right side, what will happen? Here it will get even, it will be even more negative. Negative value will increase. That's not what we have to do. So if you add minus to the left side, we can convert this to -4. To convert +6 to -4, I should add 10 OH minus. 10 OH minus. All right. Then I have not balanced hydrogen yet. How many hydrogen do I have on the left hand side? 16. 3 into 2, 6. 10 into 1, 10. So altogether 16. So to balance that, I have to add 8 water molecules on the right side. And how do you confirm whether you have done it correctly? Count oxygen. 6 here, 10 here. So it is 16. 8 here, 8 here. Again, 16. All right. Fine. Right, next one is similar to the above one. It's similar to the above one. You can see manganese from +2 goes to +4. All right. And in H2O2, oxygen from -1 goes to -2. Right. Now, if you consider the stoichiometric coefficients, +2 to +4, difference is 2. -1 to -2, difference is 1, but there are 2 oxygen atoms, therefore 2. 2 and 2. Not the simplest of ratios. So you can convert it to 1:1. Can convert it to 1:1. So let's cancel it out. Right. And then manganese is already balanced. Don't balance hydrogen yet. Just check the charges. On the left hand side, what is the only charge we have? +2. On the right hand side, is there any charge? No charge. So what should I do? I have to put 2 OH minus here and balance the charge. Now it's which 2 OH minus and +2, it's 0. Here also 0. And then hydrogen, we have 4 on the left side. Therefore, I have to put a 2 here. This is one of the easiest equations to balance. Very easy to balance this one. Okay, not very complicated, very easy. And yeah, we have 4 oxygen atoms on the other side. That's it. Fifth one. Right, 6th question. Okay, what about this one now? Manganese is +7 here, and manganese is +2 here, and manganese is plus 4 here, which is called, this is called actually a comproportion reaction. That means both manganese becoming something else. No, this manganate, permanganate actually, it's getting reduced to manganese 4 oxide. Mn2 plus is getting oxidized to this. So same, right? Plus 7 to plus 4, plus 7 to plus 4. What's the difference? 3. This is called comproportion reaction. Plus 7 to plus 4, difference is 3. Plus 2 to plus 4, difference is 2. All right. Then how many manganese do I have? 2, 3, 5. Done. 2 and 3, 5. And then we need to balance the charge. What is the charge do we have on the left hand side, people? -2 plus 6. -2 plus 6 altogether plus 4 is the charge we have. Plus 4. Here, nothing, because it's neutral. Then we have to add 4OH minus to balance it off. 4OH minus to balance it off. Then plus 4 and minus 4 will become 0. Then next, oxygen. We have 12 on the, no, we had to balance hydrogen. Sorry, we had to balance hydrogen. 4. You can balance oxygen also, doesn't matter. 4 hydrogen on the left hand side. Then you put 2 water on the right hand side. Then it will be balanced. Look at oxygen. We have 12 on the right side. We have 12. That's it. 7th one. Again, permanganate. Again, permanganate. Now it's plus 7 here. This is a bit challenging. Let's see. Plus 7, and here permanganate is plus 6. Here, sorry, manganese is plus, from plus 7 it has gone to plus 6 and plus 4. Well, this reaction is actually a disproportionation reaction. This reaction is a disproportionation reaction because permanganate has become manganate and MnO2. So we have learned before, disproportionation reactions must be balanced from the right side. That's the easiest way, right side. Okay, how do you balance it from the right side? What's the difference between this and this? Plus 6 plus 7, difference is 1. So that 1 should be put here. We don't normally put that 1. I'll just put a dot instead of that. This dot means there's a 1 here. Plus 4 plus 7, difference is 3. That 3 should come here. It's a disproportionation reaction, remember. Okay, and then 3 manganese, 4 manganese altogether on the right side. Therefore, I have to put a 4 here. Okay, right. Now, if you look at the left-hand side, so far, what is the charge without the OH minus? Don't disregard the OH minus for a while. Without OH minus, what is the charge we have? -4, without OH minus. And here, the charge we have is -6. -4, -6. Therefore, I have to put a 2 OH minus here, then -4, -2, again, -6. This is a disproportionation reaction. You should start from the right side, okay? Then you have to balance hydrogen, people. 2 hydrogen here. Then you have to put a water molecule on the left hand side. It will be balanced. Now, check the hydrogen atoms. Is it correctly balanced? 18. There's a mistake here. Something has gone wrong. Now, I'm sorry, earlier I made a mistake in the reaction, writing the reaction. So I have changed the products now. Permanganate does not undergo disproportionation in basic medium, but manganate undergoes disproportionation in acidic medium. So I had that in my mind, and by mistake I have written here per previous reaction. We were struggling to balance it. There was a problem because the reaction was wrong. But now this is the this is a correct reaction. When you have permanganate, which is a purple color solution, for that if you add concentrated sodium hydroxide or potassium hydroxide, that purple color solution will turn into a green color solution while evolving air bubbles, or gas bubbles, not air bubbles, gas bubbles. What happens is it turns into manganate. You will learn this in grade 13 inorganic. So for the time being, let's focus on balancing this equation. Now this equation is a special case because this OH minus acts as 2 things here. It acts as the reducing agent. It is getting oxidized. So it is the reducing agent here. It is the reducing agent. And also it acts as the medium to reducing agent, and it acts as the medium as well. Why do I say medium? Because it provides OH minus to the solution. So it acts as the medium also. All right. So when you consider, you have to consider that and only balance it. So here you have to go for that trial and error method. You put a number, again you will have to change this number to balance it. Right, now let's start with the normal way we start. +7 is the oxidation number of manganese here, +6 here, -2 here, 0 here, oxygen. It has got oxidation. Right, +7 to +6, that's it. The difference is 1 actually, 1. I'll put a dot here. Okay, and -2 to -2 to okay, -2 to 0, difference is 2. Now I put a 2 here and a 1 here. If I put a 2 and a 1 here, there is a problem, people. Whatever the number I put here, I have to balance this oxygen. With whatever the number I put here, I have to balance oxygen, because OH minus is the one, a part of not all OH minus, a part of OH minus is turning to O2. But the problem is with this one, I can't balance this O2. So what should we do? This is 2:1. We have to make it 4:2. We have to make it 4:2, right? Then with this 4, you have to balance manganese. With this 2, you have to balance this oxygen. 2 oxygen, it's already balanced. So I'll put a dot here. But if you consider the charge again, the charge, it is not balanced. Look at the charge now. What is the charge on the right side? -8. What is the charge on the left side? -6. Charge is not balanced, right? So what we do is we get rid of that 2. We get rid of that 2. And instead of that 2, what do? We substitute a 4. So I will leave that 2 the way it is, and yeah, I'll put a cross around it like this. You can't see the cross, sorry. Why am I cancelling that 2, people? Because if I leave it that way, the charge is not balanced. On the right side, we have -8. On the left side, we have -4. So that 2 must be changed to 4. That 2 must be changed to 4. Then only charge will be balanced. Okay, 4, -4, -4, -8, and -8 here. And finally, we need to balance oxygen. And how do we? Oh, no, sorry, water. We have to add water to balance hydrogen. We have 4 hydrogen here. No hydrogen here. Therefore, I have to put 2 water molecules on the right side to finish this off. Plus 2H2. Right, then count oxygen and see. 16, 20 oxygens atoms on the left side. On the right side, 16 plus 2 plus 2, altogether 20. That is how you balance it. An exceptional case. This is an exceptional case, trial and error method. So we have, in the previous cases also, we have discussed such questions. Around 4 to 5, we discussed, I think, no, 3 to 4 maybe. So keep this in mind. Practice them again, you will get it. Now, few more examples for this kind of reaction. I will just write them here. You guys check that out later. When copper reacts with concentrated HNO3, or when copper reacts with diluted HNO3, or when MnO2 reacts with concentrated HCl, when CrO3 reacts with concentrated HCl. All these examples, we handle them in this way. So if you go back and study these examples, you will understand this even more. Okay, not only copper plus HNO3, you can also say magnesium plus concentrated HNO3. Both the reactions are more or less same. Likewise. All right, fine. So these also were balanced in the same way. Now let's move on to the 8th question. Permanganate, right, as usual, +7. Now we have Cn minus and CNO minus, right? +7 permanganate has gone to +4. +7 has gone to +4. The difference is 3. Let's settle it down, right? It's settled. Now we have an issue with Cn minus and CNO minus. So what are these two? Cn minus and CNO minus. Talking about Cn minus, it looks like this. This is Cn minus. Now Cn minus is this. This is the structure of Cn minus. Yeah, carbon has a negative charge on it. All right. So in this, no, nitrogen doesn't have negative. Carbon has negative charge on it, and the charge of the oxidation state of carbon in that is +2. Nitrogen is -3. Total charge is -1. So carbon is +2. Okay. In CNO minus, now CNO minus should look like this. CNO minus. How should we draw it? Okay. Nitrogen, triple bond, oxygen, carbon, oxygen. If you draw the most acceptable Lewis structure, then it has to be like this. Oxygen should have the negative charge. Carbon should have 4 bonds. Here, carbon has the negative charge, therefore it can have 3 bonds. Okay, this is CNO minus. And this is Cn minus. All right. And in this one, what is the oxidation number of carbon now? Plus 4. Oxidation number of carbon is plus 4. Oxidation number of nitrogen did not change. It is minus 3. Here also it's minus 3. So carbon is the one who is actually getting oxidized. So just below carbon I have written plus 2. Just below carbon I'll put plus 4. All right. Fine. So that's something you have to figure out if you get a question like this. But in the advanced level paper, highly unlikely that you might get a question like this. If they give you a reaction like this, most probably they will give you the whole thing, people. They will most probably give you the whole reaction, because this is not in our syllabus, but I just want you to push your limits. Right. From plus 2 to plus 4, difference is 2, and that 2 goes in front of manganese. Okay. 2 manganese, you will balance that. 3 carbon and 3 nitrogen, you will balance that. Right. Let's balance oxygen later. Don't worry about oxygen. And then, as usual, we have to consider the charge. On the left-hand side, the charge is minus 5. 2 minus 3, right. And on the right-hand side, the charge is minus 3. Right. Minus 5, minus 3. Therefore, we have, this side is more minus. So I have to put 2 OH minus to balance it off. And then what is remaining? I think I should put 1 water molecule. Here 2 hydrogen atoms, no hydrogen atoms. So I put 1 water molecule. Right. To make sure we have done it correctly, let's count. The oxygen atoms. We have 9 here. 8 plus 1, 9. Here we have 3, 7, 2, 9. So we have done it correctly. This should be the correct one. Okay, 2, 3, 1, 3, 2, 2. Right, 9th one. It should not be a very difficult task. Chlorine is 0. Sulfur plus 4. Here, chlorine is minus 1. Here, sulfur plus 6. But we are balancing it in acidic medium, basic medium. Chlorine from 0 to minus 1, difference is 1. But there are 2 chlorine atoms, so I have to put a 2 here. I have to put a 2 here to balance it. Sulfur from plus 4 to plus 6, difference is 2. So I have to put that 2 here. But again, what's the problem? 2 is to 2, that is not the simplest ratio. So let's simplify to 1 is to 1. 2 chlorine atoms, let's put a 2 here. Sulfur is already balanced, 1 sulfur, 1 sulfur. And then let's go for the charges. What is the total charge here? Minus 2. Here, minus 4. And let's add 2 minus here, 2 OH minus to balance the charge. So minus 2 and minus 2, minus 4. Here also minus 4. Then water must be added. 1 water molecule must be added to the right side to balance hydrogen atoms. 2 hydrogen, 2 hydrogen. Overall, what is the number of oxygen atoms on the left side? 5. On the right side also 5. So it's done. Right. I hope that is clear. That's not that hard. Okay. Much manageable, that one. Right. This is important. 10th one. Reaction of aluminium in the basic medium with nitrate ions. One of the most popular reactions in chemistry. Aluminium starting from 0 has gone to plus 3. Inanimate, aluminium is plus 3. Nitrogen, careful, from plus 5 has gone to minus 3. From plus 5, in nitrogen is plus 5. In ammonia, nitrogen is minus 3. Now, aluminium from 0 to plus 3, difference is 3. So that 3 is here. Nitrogen from plus 5 to minus 3. What is the difference there? It should be 8. Plus 5 to 0, 5. From 0 to minus 3, another 3. Altogether 8. Plus 5 to minus 3. Now plus 5 to plus 3 means 2, correct? But plus 5 to minus 3, you should have put 8 here. All right, 8 aluminium, 8. 3 nitrogen, 3. Then let's consider the charge like we always do. What is the charge here, people? What is the charge? We have total charge of minus 3 on the left hand side. And on the right hand side, minus 8. So right hand side is more dominant when it comes to negative charge. Left hand side, we need more negative charge. So let's put 5 OH minus. Okay, and then I think we will have to add water also on the left hand side, not this time, because I have 9 hydrogen atoms on the right side. I have only 5 hydrogen atoms on the left side. So let's put 2 water molecules like this, and 16 on the right side, and here 9, 14, 16 on the left side. One of the most popular reactions. You need to know this. You can't expect to remember this by heart. 835283. You should have the practice where you can do this within one minute and finish it off, balance it quickly. That's the kind of practice you need. So if you understand the basics, it's not going to be that hard, right? Same concept we can apply for the next question also, and let's finish it off quickly. Zinc 0, from 0 zinc has gone here. In zincate it is plus 2. Nitrogen here it's plus 3, and it has gone to minus 3 in ammonia, right? Now talking about zinc, from 0 to 2, difference is 2. And NO2 minus from plus 3 to minus 3, difference is 6. Plus 3 to minus 3, difference is 6. Now what's the problem on the left side? 6 and 2. I think that is not, it's not the simplest of ratios. So let's convert it to 3:1. 3 and 1. All right, 3 and 1 is here. 3 zinc, so I'll put 3 here. 1 nitrogen, 1 nitrogen here. All right, good. Now we have to balance the charges. Nitrogen is balanced, zinc, correct. What is the charge we have on this side? It's minus 1. We have minus 1 as a charge on this side. And here the charge is minus 6 on the right side. Charge is minus 6 on the right side. So on the left side it's minus 1, on the right side is minus 6. I have to put 5 OH minus to balance it off. Right. And I have 5 hydrogen atoms on the right side. I have only 3 hydrogen atoms on the left side. So we have to put 1 water molecule on the right side. Now I'm getting a question asking about can we have both OH minus and water on the same side? That's totally fine. That's totally fine. They both can be on the same side. That's totally fine. It's okay. That happens if the product also has hydrogen. Okay, if something else other than water and OH minus, if something else has hydrogen, then there's a possibility of both OH minus and water being on the same side. Hope you can understand. Why do we have water and OH minus on the same side here? Because in ammonia we have hydrogen, people. That's why. In all the other cases, you can see both hydrogen and water are on either side because they are the only hydrogen containing species. But here we have ammonia. That's why this exceptional case is happening. Right. Now we are done with the last one, but we have to confirm whether we have done it correctly. Count oxygen. 2 plus 5, 7. 6 plus 1, 7. We have done it correctly. So that's it. That is the 11th one.